this class, we'll be discussing about operators in Java language. So generally, operators are mostly frequently used whenever we are performing some operations like evaluating the expressions or performing some arithmetic operations, logical operations, and all these operations involves some operators. So coming to the operators, operator is a symbol which is used to perform an operation on the operands. Here, we can define the operator is a symbol which is used to perform an operations. There are the different type of operators like binary operators and unary operators. Binary operators means suppose if you take this one, I would like to add two numbers a and b. So to add these operators, I use the symbol called plus. That means here the plus is called as a binary operator which requires two operands. These are called as a binary operators. Some operators comes under the binary operators category. There are some operators which takes only one operand. Those are called as a unary operators. And for example, suppose there is a, I want to negate the value of a, or simply I would like to increase the value of a by 1. This is a plus plus. So the operators which requires only one operand for performing the operations, those are called as a unary operators. So we'll see what are all the different type of operators are available. These are the categories of operators: unary operator, binary arithmetic operator, shift operator, relational operators, bitwise operators, logical operators, ternary operator, and assignment operator. So we are going to see each and every operator in detail. See this one. Under the unary category, uh, there are two types. One is postfix and prefix. Postfix means if there is an expression or a variable and the operator is appeared after the expression or the variable, then it is called as a postfix representation. Whereas prefix representation means first operator is represented followed by the expression or the variable name, and these are called as a unary operators which requires only one operand or one expression. Next category of operators are arithmetic operators. So most frequently used operations like addition, subtraction, multiplication, division, and modulus operators. Those are all comes under the arithmetic operators. Another one is shift operator. There are the two types of shift operators. One is called as a left shift, two less than symbols. Other one is called as a right shift, two greater than symbols. And shift operators are working on the individual bits of a digit or a variable. Next one is the relational operators. Relational operators are used to compare two operands or two expressions. Here, these are all the symbols comes under the relational operators: less than, greater than symbol, less than or equal to, greater than or equal to. Instance of this is the one more relational operator which are used to compare the two objects in Java language. Next one is the equality, to check whether two variables are equal or not. For that we use the two double equal symbols, and not equal to is used to check the inequality between the operands. Next category is bitwise operators. There are these operators are called as bitwise operators. One ampersand symbol, this is called as a bitwise AND operator, and this is pipe symbol, bitwise OR operator, and this cap symbol is this bitwise exclusive OR operator. And these shift operators as well as the bitwise operators are works on the individual bits of the variables. Next one is the logical operator. Logical operator is used to combine two expressions. For example, I would like to test two conditions. If I want to take the decision if both the conditions are satisfied, then I'll be using the logical AND operation. Suppose I would like to evaluate the expression if any one of the conditions are satisfied. Then we can go with the logical operations. So by using these two, we are be able to evaluate the expressions. And the outcome of these logical operations are Boolean. That means it will be giving you true or false as output. Next one is the ternary operator. Ternary operator is the replacement for simple if-else statement. This is the question mark and colon symbols are there. First, we are going to take one expression. If the expression is evaluates to true, then we are going to write certain statements after the question mark symbol. If that expression evaluates to false, then what we are supposed to do will be written after the colon statement. Next one is the assignment operator. Assignment operator is used to assign a right side value to the left side variable. It is not only for that, you can also perform evaluate some expressions plus equal to. For example, a plus equal to 10, which is same as a equal to a plus 10. So like this, you can apply that assignment operators for all these arithmetic operations as well as for the relational operators. So we are going to see all these operators in example with the help of the program. And coming to that, suppose uh, we would like to evaluate an expression. For example, look at this. I would like to evaluate the expression like this. 10 plus 5 into 3 minus 2. So the combination of operands and operators according to the syntax, then it is called as an expression. Now I would like to evaluate this expression. Now there is a ambiguity that first do we need to perform the 10 plus 5 or 5 star 3. For all these operators, there is some precedence while evaluating the expressions. According to the order of precedence only, we need to evaluate the expression. So if an expression consisting of all these operators, the first preference will be given to the parenthesis. Parenthesis means the expression within these braces are called as a parenthesis. These are the parentheses. If an expression consisting of these parentheses, first the value present in this need to be executed. For example, if there is an expression, when compared with all these, which one has come first? The multiplicative. Multiplicative means here we need to perform this operation. 5 into 15. 5 into 3, 15. Next, the remaining values will be as it is. 10 plus 15 minus 2. After that, additive operations. Now 10 plus 15 is 25. Next, minus 2, 23. So if the expression is like this, then we need to evaluate this first. For example, the same expression, first if there is parenthesis for this part, then we should not evaluate the 5 into 3. First we need to evaluate the expressions within the parenthesis. Then this value will become 15. Next, into 3 minus 2. After this, from left to right, highest precedence is multiplicative. This is 45 minus 2, it is 43. See that based upon the expression, because of the presence of these braces, the value has changed. And here, these are the order we need to follow for evaluating the expressions. This is called as order of precedence. If an expression consists of the parenthesis, first preference will be given to the parenthesis, followed by the postfix, prefix, multiplicative, after that additive, relational, followed by the logical, at last assignment. Now we are going to see all these operators with the help of an example. I have written the entire program in a entire all the operators covering in a single program. So what I'll be doing is I'm going to show you the each operators separately, and if it needs some kinds of explanation, I'm going to give that explanation also. I have created a class called operators, and within the class I created a main method, public static void main. There I would like to show the output of the unary operators. Initially we are taking the value of x as 10. Now here we are performing the x plus plus. X plus plus means here the operator is specified, plus plus symbol is the unary operator which is specified after x. This is called as a post increment. Here x plus plus. Since this operator is specified after the operator, this is called as a post increment. Now in the post increment, now the next statement is the operator is specified before the operand, plus plus x. Since the operator is preceded, this is called as a pre-increment. Now in both cases, value of x will be incremented by 1. Then what is the difference between the pre-increment and post-increment? In both cases, if the value of x is increased by 1. So the difference lies once it is allocated assigned to another variable. For example, look at this. Now I am taking the value of x equal to 10. I am taking the value k equal to x plus plus and p equal to plus plus x. Now I write the values of the k, p and x. Now coming to this expression, here what is the value of x? It is 10. The value of x is 10. Now since it is the post increment, first the value of x is assigned to the a first, and then the x value is incremented by 1. In that case, what will happen here is first the value of x is assigned to the x k. Now the k value will become 10. After assigning, the value of x will become incremented by 1, then x value will become 11. Now the latest value of x is 11. Now coming to the next statement, here this is the pre-increment. In the pre-increment, what will happen is first the value of x will be incremented by 1. That means the value of x is incremented by 1, the new value of x is 1. And after incrementing the x, then it will be assigned to the variable. Now the value is 1. If you observe clearly, in both cases the value of x is incremented by 1 either in pre-increment or post-increment. The only difference is while assigning these values to the variables. If it is the post increment, first x is assigned to the variable and then incremented by 1. If it is the pre-increment, first incremented by 1 and then the incremented value is assigned to the p. So that is represented here. So if it is the x plus plus, first x value equal to 10 is displayed. After displaying, its value will be incremented by 1. In this case, pre-increment. Pre-increment means the current value of x is 11 and after incrementing the value has become 1. Similar to that, this is the post decrement and this is pre-decrement. And the current value of x equal to 12. In the post decrement, first x value is printed. First 12 is printed and then it is decremented by 1. Now it has become 11. In this case, the current value of x equal to 11. After that, it is decremented by 1 and it has become 10. So like this, the pre-increment and post-increment operators works. These two comes under unary operators. And similar to that, there is one more expression. Here what we are doing is, first this is the post increment and this is the pre-increment. See how these values will change. What is the value of a? It is 10. A plus plus. That means first the value of a will become 10 and then I is incremented by 1. After this statement, a value will become 11. But first a plus plus means it will be 10 only. After that, plus plus a. So after incrementing the value of a, it is 11. Since it is the pre-increment, this value will become 12. 10 plus 12 means it is 22. Now coming to this one, the value of b is 10 here, and since it is the post increment, b plus plus means here it will take the value of b as 10. After this, the b has become 11. Now here also it is the post increment, the b value taking the value as 11. Then this value will become 21. And if you observe clearly, these operators takes only one operand. That is the reason these are called as a unary operators. The next one is we are taking the two more variables, a equal to 10 and b equal to minus 10, and two more variables. This time these are the Boolean type of variables. One is true, other one is false. And this is negation of a. Even this negation also, it takes the only one operand. Negation means it is the called as a 2's complement. 2's complement of a is 10. Look at this. And negation is working on the individual bits. Here the value of a equal to 10. How do you represent that in binary form is? Binary equivalent for 10 is 1010. These are 4 bits. If you are representing that with 8 bits, then these are the bits. Now, complement of 10 means it is the tens complement. Tens complement is 1's complement plus, this is 1's complement plus 1, then we are going to get the 2's complement. Now, negation means it is the 2's complement. Now, this is the plus 10. How do you get the minus 10? How do you get the negative this complement? We need to get the 2's complement. 2's complement means first we need to calculate the 1's complement. This is 1's complement is 1's are replaced with zeros and zeros are replaced with 1. So 0 is replaced with 1 and 1 is replaced with 0 and 0 is replaced with 1. This is 0 and these are all 4 ones. This is the 1's complement. And how do you get the 2's complement? For the 1's complement, we need to add 1. So 1 plus 1 becomes 0. This 1 carry. Here this is 1 and this is 1. This is 0 and all these are 1's. So here the most significant digit indicates it is the sign bit. If it is 1, it indicates it is a negative number. The if the most significant bit is 0, it is called as a positive number. For 1 it is negative, for 0 it is positive. So here we got the most significant digit is 1, indicates that the result is negative number. And this is the value here, it is minus 11. This is minus 11. So minus 11 is represented in the 2's complement form, then we get this value. For example, you take the value of 11. The binary equivalent for 11 is 1011, and we are representing this 8-bit representation. And how do we represent the minus 11? This is the 2's complement to this. How do you get the 2's complement? This is 0, this is 0, 1, 0, all ones. And for this, we need to add 1. 1, 0, 1, 0, 4 ones. So this is the value which we got here, and this is equivalent to minus 11. That means if you are given the value 10, so negation of 10 will gives you minus 11. Okay. So complement of A gives minus 11. Similarly, complement of B. Complement of B means B value is minus 10. Here minus 10 means we need to represent that in the 2's complement form. And for that, again, if you calculate the complement, then we get the value as 9, similar to the previous one. And this is called not operator. And the value of B, C is declared as true, and negation of true is false. So for this statement, we get the output as false, and the D value is declared as a false, and negation of D will gives you true. So this is all about unary operators. So we'll compile this code. Javac operators.java. Next, I am executing that by providing the dot class file. See this one. The post increment value, we got this as 10. Next one is, sorry, this is 10. After this, pre-increment value we got as 12. This is 12. Next, post decrement is 12. This is the 12. And pre-decrement value is 10. Pre-decrement value is 10. So here the value of 10. Next one is performing the arithmetic operation on these two values, which leads to 22 and 21. And these are the two values, 22 and 20. Now we are taking the value of A and B as 10 and minus 10, and C and D as true and false, and we are calculating the complement of these values, which leads to minus 11, 9 false and true, and we are getting the same output, minus 11, 9 false and true for this. This is all about unary operators. The next one is arithmetic operators. So I use the same program, but I'll follow the different, I am commenting the unary operators. Now I'll check with the binary operators. Sorry, arithmetic operators comes under the binary operator. Binary means which takes the two operands. So it is most frequently used addition operation, subtraction operation, multiplication, division, and modulus. And A value and B value are 10 and 5, 10 plus 5, 15, 10 minus 5, 5, 10 into 5, 50, division operation 10 by 5 is 2. And modulus operator gives you the remainder. Since 10 is divisible by 5, the remainder is 0. The next one is shift operators. Shift operators are used to perform the bitwise movement. Either you need to move the bits towards the left or towards the right. Before that, I'll be showing you both arithmetic operators result as well as the shift operators results at a time. See that this two less than symbols are called as a shift left operators, and two greater than symbols are called as a shift right operators. I'll show you how these operators work. For example, uh, x is a number. For example, x is a number. I would like to perform the shift left operation n times. Then the result would be x multiplied by 2 to the power of n. For example, x value equal to 10, and we are performing the left shift operation on 10 two times. Then the result will be 10 into 2 to the power of the n value equal to 2. 2 to the power of 2 means 4. 10 into 4 is 40. How this will become means, for example, what is the value of 10 in binary format? In 8-bit representation, 1010. So this is called as a most significant digit, and this is called as a least significant digit. And if you observe, if you go towards the left side, the magnitude will increase. Now what we are doing, we are shifting the bits towards the left two times. Suppose if you are moving the bits towards the left, this most significant bit will be lost. Now this will be coming and occupying this position, and this and occupy this position. This will occupy this position, and this will come in occupy this position. Now what will happen? These three zeros move to the left, and this one will occupy here. This one, this one. Now this will be 0. This, how many times we have shifted? Only once, but we are supposed to fill two times. Shift. That means again one more time we need to move. This will become 20. Now this place will be occupied by the next one. Next one, this value will become 30. And this one is this. And this value is 2 power 0, 1, 2, 4, 6, 8, 32. Sorry. 2 square, this is 8. This is 16. And this is 32. The corresponding positions where 1 is available is 32 and 8. So the value will become 40. So a blind rule is that if you are having a number x like this, and if you are shifting that x towards the left n times, then the result is x into 2 to the power of n. The same thing if we are moving the bits towards the right. So x shift right of n means the value will be divisible by 2 to the power of n. The reason is most significant digits are towards the left and least significant bits are towards the right. If you are moving towards the right, what will happen? This value will come and occupy this place, and this value will come and occupy this place, and this will come to this place, and this will be lost. So if you are moving towards the right, the value will be decremented, and if you are moving towards the left, the value will be incremented. It is in the powers of 2 only. So this is the way how the shift operators works. Left shift and right shift. This is right shift. Right shift means this symbol, two greater than symbols. Then this division will take place. Now going to the program. Ten left shift of 2 means 10 into 2 to the power of 2. 10 left shift of 3, 10 into 2 to the power of 3. 20 left shift of 2 means 20 into 2 to the power of 2. Similarly, this one. In all these cases, the value is multiplied with powers of 2. 2 to the power of these values. Next one, this is the right shift operator. If you are moving the bits towards the right, then these values are divisible by, divided by 2 to the power of n. 10, 20 divided by 2 to the power of 3. Then we get these values. Now I'll show you this, how this works. Now this time I run the both arithmetic operators as well as the shift operators. Once again, I'm compiling the program. There are no errors. See these values. Arithmetic operations, addition, subtraction, multiplication, division, and modulus values. So 15, 5, 52, and 0, we got the same values. Next one is the shift operators. Shift operators performing the left shift these many number of times, we got the values 10, 80, 80, and 240. After this, we performed the right shift operations, which are divisible by 2 to the power of n. These are the values. So this is all about arithmetic operators and shift operators, and we have seen the unary operators. Next one is we'll look into the logical operators. So logical operators means there are logical and two ampersand symbols and logical or two pipe symbols. Generally, logical operators are used to perform the operation. I think most of you people know that if you are going with logical AND operators, there are logical AND operators are there and logical OR operators are there. Logical AND means two ampersand symbols. Logical OR means two type symbols. You know the truth table. Suppose this is the one expression, expression 1, and this is another expression. If we are using the logical AND operation between the two expressions, this value leads to true only when if both the expressions are evaluates to true. For example, I'm taking the value of a equal to 10, b equal to 15, and c equal to 15, 20. I check the operation a greater than b and b less than c. Now, if both the conditions need to be satisfied, then we should use the logical AND operation. So what is the value of a? 10 and 15. 10 greater than 15, this is false. And b less than c, this is true. And if one of them is false, the entire expression will be evaluated to false. Whereas logical OR operator, instead of AND, if we have the OR operator, like um, instead of this, if we have OR operator, in the OR operator, if any one of them is true, then the result will be true. In this case, a greater than b, this is false, and b less than c, this is true. And if we are using the logical operator, then the entire expression will be evaluated to true. So this is the difference between the logical and logical OR operator. In practical, suppose if a student needs to appear for the placements, then there are the two constraints. One is he should have the CGPA above 8, and the second one is he should not have the backlogs. And if we want to allow him, if both the conditions are satisfied, in that case we can go with the logical AND operators. If one of them is satisfied, if you want to allow that, then we can go with the logical operators. Now to move into the program, see this, the value of a, b and c are like this. A less than b, a is less than b, the condition fails here. And if you observe, it is the logical AND operation. If the first condition fails, then the logical AND operator won't check for the second condition. Why? Because if one of them fails, even the second expression is true also, it won't give you the correct answer. For example, look at this. Here it has become false. If it is false, even though this become true, then the entire result is false itself. Why? Because the first expression is false. So logical AND operator, how this evaluates is, if the first expression is evaluates to false, then it won't check for the second expression. Directly it will give the value as false. But coming to the OR, if first expression is evaluates to true, logical OR, then the second expression it won't check. Why? Because if one of them is true, the result itself is true irrespective of the second condition. Even if it is true or false, doesn't matter. For logical OR operator, since it is true, the entire result will be true. So this is the way how the logical operator works. Next one is bitwise operators. And the bitwise operators are represented with one ampersand symbol, and bitwise OR operator is represented with the one pipe symbol. And generally bitwise operators are used to perform the operations on the individual bits. For example, I would like to take two numbers. One is 5, another one is 7. I would like to perform the logical AND operation. So sorry, this is bitwise AND operators. So bitwise AND between the two numbers 5 and 7. 5 is represented with binary format 0, 1, 0, 1. I am taking only 4 bits. 7 is represented with 0, 1, 1, 1. Bitwise AND means if both the values are true, then the result is true. So this is 1. If one of them is false, the result is false. And 1 and 0. That means if we are applying the bitwise AND between the two numbers, then this value will become 5. The same thing if I am applying the operators bitwise OR operator between these two, then it looks like this. Now here I am applying the OR, and if any one of them is 0, the result is 0. Bitwise OR means if any one of them 1 is 1, the result is 1. This is 1, and here it is 1, and here it is 1, and this is also 0. The bitwise operator means here we get the value as 7. So generally bitwise OR operators focus on the individual digits of the number. So here generally it will be used for the bits, but it can also be used along with the expressions. See this one, same expression we used for logical AND operators. The difference between the bitwise operators and logical operators is in logical operators, if the first one is false, in logical AND operators, it won't check the second expression. But bitwise operators, even though it is false, it will be checking the second expression. This is the difference between the logical and bitwise operators. Now this is the bitwise OR operator. First, it will be checking the condition. Even if it is true or false, it is going to check the second expression. It is opposite to the logical OR operator. Next one is the ternary operator. Ternary operators are used to simply replacement of if-else statement. See this. This is the expression. If this expression evaluates to true, this part will be executed. That means the expression after the question mark. If this expression evaluates to false, the second part is executed, that is after the colon statement. For example, I would like to check whether the given number is even or odd by using the ternary operator. Now what I will be doing is I am taking the value of x. I want to check whether the x is even or odd by using the ternary operator. First I will write the expression x mod 2 equal to 0. If it is 0, then this part has to be executed like system.out.println. It is even number. Suppose if this evaluates to false, then I have to specify that by using the colon. and there I will need to represent the system dot out dot println, and it is uh, so true part after question mark will be executed if it is false part after colon part is executed. And in this example, we are displaying the minimum between the A and B. If A is less than B, it is true, then A, otherwise B. So that value is stored in the minimum variable and the value is printed here. The next one is the assignment operator. In the assignment operator, we are taking the value of A and that is assigned to the variables. Here, suppose A plus equal to 3. Here, A plus equal to 3. It is same as A equal to A plus 3. Suppose if I am taking the x equal to 10, x I equal to 2. This means x equal to x by 2. This also comes under the assignment. This is called the shorthand notation, and in that context, A value equal to 10 plus equal to 3 means 10 plus 3. A minus equal to 4 means the current value of the A is 13 after updation. Then 13 minus 4, and star equal to means A equal to A into 2. The current value of A is 9. It is multiplied with 2. So like this, we can perform the assignment operators. Now I'll execute the code. It will show the output of the logical, bitwise, ternary operators and assignment operators. Java C operators.java, Java operators. The logical operators, see the code. The logical operators, this is false and this is true, and end operation will be leading to false. So that is the reason the output is false. Next one is this is true and this is true. Or operator both are true, the result is true. Next one is bitwise operators. The bitwise operators, as we have seen, first one is false and the next one is true. So these are the outputs. And in the ternary operators, the minimum value equal to 5 and the value is 5 is displayed. Next one is assignment operators. These are the values. So this is all about the operators. We have seen all the operators, unary operators, arithmetic operators, shift operators, relational operators, bitwise operators, logical, ternary, and assignment operators with examples and how each operator works. Unary, arithmetic operators, shift operators, logical, bitwise, ternary, and assignment operators. So this is all about the operators. Almost in all programming languages while evaluating the expressions we use these operators.